Let's have some fun. Okay, we're going to be working with probability, that's probability density function. With continuous random variables. Sounds like a mouthful. Before I delve into the new stuff, I want to go back and review 4 topics of old stuff. If you can do the 4 topics of old stuff, you'll be absolutely fine with the new stuff. Okay? So the first thing we're going to review is we're going to look at a probability distribution function. And I feel like you're going to be okay with this. It's been a while, but I think you're going to be totally okay with this. I say that trying to convince myself and you at the same time. When you're done drawing it, I'm going to talk about it. Distribution functions from back in the day. If you look at this, this is some scenario of probability. If you have the values of x are, in this particular case, 0, 1, 2, 3, and 4, the probability of x when x is 0 is 0.2. The probability of something happening when x is 0 is 0.2. The probability of something happening when x is 1 is 0.3, and so on and so forth, okay? Things that we had to remember from way back in the day. There's something very special about the probabilities of all of that particular scenario.
Equal to 1.
They add up to 1, exactly right, okay? So we know that this, from 0 to 4, is 100% of what we were talking about for this particular situation. So if indeed this adds up to 1, are you able to solve for p? Yes. Okay, literally that plus that plus that plus that. 1 minus that answer is p. Okay, so go find p for me. P. What do we get? Point what? 0.1. So p is 0.1. Okay, any comments, questions, concerns? Are we cool with that thought, right? Old school, we've done this before. Yay, I love you. Okay, good. So the next thing we're going to do, as far as a probability distribution function, we're going to talk about E of x. E of x is referred to as the expected value of x. It's been a while. Expected value of x also has another name, one that we might be a little bit more familiar with. It's called the mean. So it's the average of this particular probability function. And the equation that goes along with that is p times x. So, hold on 2 seconds. We're going to take not only p of x, we're going to do this of it. What am I asking us to do of it? To find the sum of.
Is it capital P or lowercase p?
Capital P. I don't know. Something. P. Okay. So literally what it is you take the x value times its particular probability, the x value times its probability, and so on, and then do what with those answers? Add them up. So your average mean, also known as expected value of x, is these multiplied, those multiplied, all the way down the line, and then add your answers up, okay? So if you don't mind, go ahead and find your expected value. What did you say?
1.7.
Okay, I think that's what I remember from last night. Any questions, comments, concerns, issues? No? Yes? Maybe? So 0 times 0.2 plus 1 times 0.3 plus ... 4 times 0.15. Okay. Now, also, a review from the past is to find the variance of x. Can anybody remember that at all?
Isn't it like you subtract something from something, like you subtract the mean from something, you square it, and you add them all together and divide by n minus 1?
Oh wow, you are giving me lots of good stuff. Yeah, good stuff. Very close. I was with you with the subtraction thing. So it is this. Let's see if we can remember, if it rings a bell. It's the x's get squared. We multiply by the probabilities. We add that all up. And then we take the mean that we just found, we square that puppy, and we subtract it from what we just did. I don't know whether these are on your bright colored sheet of paper.
They are.
They are?
Yeah.
Oh, that's beautiful. No dividing. You were just excited for nothing. You want to divide stuff. I think the n-1 came from, no, I don't know. Yeah.
You divide by n when you do like the ungrouped and the grouped data.
Like the sum of x divided by n. Yeah. A little different. Because this scenario is every possible probability that could happen. You know, so. All right, crunch your numbers, have some fun with it.
Okay.
Yes. Somewhat. Okay. Nothing? 1.71. Awesome. Oh wait, how do we feel about that blast from the past? Are we cool? Okay, the other two things that you need to know how to do is, oh no, I thought we were doing stats, Miss Kay. All right, can you do that? All right, feeling good? No? Some of us feel good. To do something like this. Okay, solve for the positive value of A.
Is that an O or a 0?
0.
It looks very circular.
Oh, okay.
Good job.
Thank you.
Remember when you used to draw circles?
They were gorgeous.
Yeah.
Thank you. Aren't they always gorgeous? Remember when you used to draw? That's the operative word right there, is like draw. Like, did I have, I don't know, is it one of those, you can see it, but it's really not what it's supposed to be, you know? What do you see in my artwork? I know what I see, Kransky. Need some help?
Ms. K,
Yeah.
can you not take an integration if there's an x in the denominator?
There's no X.
No, I'm just saying, like,
You'd have to reduce the top.
okay, so
Or-
if it's just a
Or
number.
make it an ln of x.
Okay, so,
If it's 1 over x to the first, right?
Okay.
Does that make sense?
yeah, I was just wondering.
Okay, good, yeah, gotcha. I'm gonna erase the last guy, okay? All right, how do we feel about this so far? When we get to the place where we recognize it's a trinomial, what do we typically try to do? Just kind of factor it in our head. What's gonna happen in this case?
Is that positive and negative? Would it be 2 and negative 2 and positive 4?
Okay, so we have, and if for some reason it comes up that we can't factor, what are we gonna do?
Quadratic equation.
Quadratic formula. So in this case, we get two values of A, but I very specifically told you that my A has to be positive, okay? So the value we're gonna utilize here is 2. Okay, we have any questions? So, we're gonna be talking about something called, we're gonna be talking about distribution, probability distribution. And so when I'm thinking of a picture, let's see. Okay, let's say this is my distribution function that I'm going to be looking at. A lot of times they're gonna be given to you as drawings. And I wanna know, what's the probability that x is less than or equal to 2? So this is my particular drawing that I'm working with, and I wanna know with the probability that I'm basically going to be less than 2, okay? So do you agree the drawing goes from 0 to 2? Does that make sense? Okay, so this particular drawing goes from 0 to 2. So what's the probability that what I'm looking for is going to be less than 2? Well, it makes sense that this whole drawing is less than 2. Do you see that? So the probability that it is indeed less than 2 is going to be working on the basic area under this particular curve. The whole area under that curve is where that probability is happening that it's less than 2. So in something that's very familiar, a box, a rectangle, something that we know, how do we find the area of that particular thing?
Base times height.
So indeed, base times height, right? So I would do the length of 2 across times how tall it is, and what's the probability that it is going to be under that curve? So 0.5, right? 2/4, 1/5, whatever, right? So what's gonna happen is, oftentimes, the visual drawing or the equation that they give you is not gonna be a perfect rectangle, okay? So how do we go about finding areas of some funky equation
Integrals.
from something to something? We do what?
Integrate.
We take an integral, okay? So whatever our integral is, let's say it goes from 0 to 3, if I wanna know the probability that it's going to fall from 0 to 3, we are going to take our integral from 0 to 3 of our function. It's truly the area under the curve, okay? Hence why we were practicing how to do that over there. Are we okay? So let me show you how they set them up 9 times out of 10. They set them up as a piecewise function. Do you understand what I mean when I say piecewise function? No problems there? Okay, I'm I'm gonna erase all this. I'm gonna give us an example of a piecewise function, and we're visually gonna look at it. So, I'm gonna give us a function. We're gonna call it okay. This is our continuous random variable that we're gonna use for this particular example. This is basically giving us a visual of this function without drawing it, okay? So, specifically, from what x value to what x value will this particular drawing be located at? From 0 to 4, whatever this looks like, is going to be where our drawing is located. And what does it mean, 0 otherwise? That means, let's say we have 0 here, 4 here, funky drawing, whatever it is, okay? 0 otherwise means it has no value when it's not between 0 and 4. It's on that, in other words, it has absolutely no area under that particular curve from anything that is not 0 to 4. So the piecewise function typically is going to be laid out as, this is the portion of the graph we're concerned about, we don't care about the rest, okay? So does that make sense so far?
Can you explain it again?
Again, so this is saying from 0 to 4 is what we're looking at is this particular function, okay? And then area under this particular curve would be 0 otherwise. There's no curve. It's just a straight line that's attached to your axes. Okay, so from negative infinity to 0, there's nothing happening. Some kind of curve from 0 to 4, and then from 4 on, nothing happening. Is that okay for everybody? If you get this, you've got the hard part, to be honest with you. So if I asked you, what is the probability for this particular example, what is the probability when x is less than or equal to 2? So let's talk about what that means. This whole graph goes from 0 to 4. I only care about how much is happening, in this case, from when x is less than 2. So literally, what are the bounds going to be if I'm going when x is less than 2?
0 to 2.
I'm going to go from 0 to 2. So if I'm trying to find the probability when x is less than or equal to 2, I'm going to take the integral from 0 to 2 of my function. So 3 over 56, 4 plus 3x minus x squared dx. And I'm going to do good old-fashioned integration. If this thing said when x is greater than or equal to 2, what would my bounds have been?
2 to 4.
From 2 to 4. Okay, so go ahead, take an integral. What can I do with that funky 3 over 56?
Bring it for a ride.
Bring it for the ride. Integrate the easy stuff, put that back in at the end. All right, give it a whirl, see how you do. All right, what are you getting? Anybody getting an answer?
17 over 28.
What'd you get?
17 over 28.
Which, when you put that in, what do you get for a decimal?
0.607.
That's what they're getting, yeah. How'd it go? Yes? No? You found the probability that, between 0 and 2, 61% falls between 0 and 2, under that curve. Does that make sense? If it's a straight curve, it would be pretty easy to kind of visualize how much percent falls under, but it's not. In this case, it's a squared, upside down. So you're seeing this a little bigger towards 0. All right, how do we feel? Awesome? Okay, good. All right, let me give you another one to try. I'm gonna give you a continuous random variable here. All right, are we good? Yes? Am I right? Was Kaylon right? You guys would be okay with this lesson? Nothing. Is it because it's Friday? Oh. So I have a function. Oh my gosh. Hello? Nothing yet, why? Nothing. All right. Okay, so this problem says initially it wants us to find k. And then we have some other things to do. But first we have to get over the hurdle of finding k. So this is a probability density function, which means it's showing the whole graph. The graph is going from what to what? 1 to 3. So we need to find the unknown k. So how are we going to start to set this particular problem up? An integral from what to what?
1 to 3.
Yep. Of.
The k x is 1.
Okay. And dx. And then it's going to equal something.
1.
Why 1?
Because that's to all the probability.
All the probability from 1 to 3 is 100%. Is 1. So it's equivalent to 1. Does that make sense? Go ahead.
Will it always be equivalent?
Always equal to 1. If you go from point A to B, does that make sense?
Yeah.
Like if this was 0 to 4, then we would have to integrate from 0 to 4 to make it one whole.
Yeah.
Yeah?
But it would still equal the whole.
Always. Mhm. As long as you're using both ends
As the boundary.
as your boundaries. Perfect. Could you all solve for k? K is just some number, so make k go for the ride, and then do your integral and solve for k. 2 plus x, right?
Yeah.
And it's gonna go from 1 to 3 equals 1. You have two options. You can bring k out and forget about it for a minute, plug your 3 in, minus plug your 1 in, get an answer multiplied by k. Or you could do plug your 3 in, multiplied by k, minus the k times plugging your 1 in.
Okay.
Both of them will do the same job.
Okay.
Does it matter if I answer with the decimal or a fraction?
I don't think it matters. I don't think it says it otherwise. Give me a fraction. Yeah, give me a fraction. Are we feeling okay about it? you get 1/6 is equal to K? Are we okay with that? Yay? Okay, now, the next piece says, sketch this function. So do you agree, we just found the K of the whole thing, so 1/6 times x plus 1 between 1 and 3. So could you draw this between 1 and 3? How do we go about drawing it between 1 and 3? One, x equals 2, and x equals 3.
Yeah, let's do one on this.
I would. As long as, if we remember drawing for the first time when we did T-charts, you had like, I think most teachers would say do -2, 0, 1, 2, like 5 numbers and connect those dots. So whatever you plug in, you just connect your dots, yeah? What is happening to our numbers? 1/3 to 1/2 to 2/3, so doing what? They're getting bigger, you know? Does it have to be a perfect drawing? No, not at all. Let's say I went from 1/3, and then I have 2/3 up here. I know at 1 it's 1/3, at 3 it's 2/3, and I know it's somewhere in the middle for that, so we're gonna have that straight line. Okay, and what I typically ask my students to do is just kind of draw a little dotted line down the side, so that way we know that's kind of the area that we're looking at under that curve. Are we okay so far? And then the next piece of this puzzle here is, it says, go ahead and find the probability when x is less than 1.5, right? So, if I'm thinking of it logically, where is 1.5 gonna be located? Between 1 and 2, huh? So here, I'm looking for the area, I'll do it in a different color. I'm really looking for the area from here to here. If I know the whole area is one whole, does that make sense? In reference, like in our brain reference, do we understand that that particular area is gonna be small? I mean, it's gonna be smaller than, and it makes sense that the thing gets larger as it goes up. Yeah? Does it make sense that the middle of it is not down the middle at 2? Because it's quite large up here, it's taller. So the area under that curve is quite considerably bigger than the area under that curve. Just wanna kinda give you perspective. So go ahead and find the probability when x is less than 1.5. And use the k you found, because that k is definitely the k now. Does it make sense that what we have here is only 19% of? Yeah, it makes sense, right? Because if you look at my beautiful drawing, you can tell it's not even the 50% of it, and it's in that lower level. How do we feel so far? We're so excited, right? Yeah. Okay, the other thing that we're gonna do, and I won't finish it today, because 5th period will be well behind, we're gonna find the median. Now, if our picture was where I started, our median would be clear cut down the middle, yay, we're good to go. But they're not always going to be beautiful like that. It's gonna be where it's a slanted line, or it's going to be where it's some graph. So if I'm taking an integral of something and I'm trying to find the median, I'm trying to find if it goes from, let's say, 1 to what would I set it equal to? If I'm looking for the median, what's median mean? Right down the middle. So all of it from 1 to 3 would be what?
100.
One whole, right, 100%. So what would the median be?
50.
50%, also known as 0.5. So you're gonna take the integral from 0 to some m that we don't know and set it equal to 0.5. It's that easy, okay? What if I said we're looking for like the upper quartile of something? What's the upper quartile?
It's the top 75.
The top 25%, also known as the 75%, right? So we would do the same thing, look for that upper quartile and set it equal to 0.75 and solve for that upper quartile, or whatever one we're looking for. And then we're gonna learn how to take the mean of it. I did a previous example on finding the mean where you take x times the probability, etc. Same concept, I'll show you that. And then we're gonna do the variance and standard deviation, which is same concept. And that, in a nutshell, is the whole lesson. What do you think? Yes? Cool? It's not terrible.